Okay, so here we have the 12 volt to 120 volt setup. Uh, Took me about 5 minutes to set up, not including the stripping of the wires um, and the joining of some wires. Okay, so I kind of had to jerry-rig some of it. Well, the whole thing's jerry-rigged, but some of it I had to jerry-rig a little more than I would have liked, just due to the limited parts and equipment that I had on hand. So to start here, we've got, let me touch those connectors in there. And we got 12.69 volts now. This is not hooked up to a charging port. It's not hooked up to the wall or anything right now. That's the battery's charge. That's how much power the battery currently has in voltage, 12.68. So basically, this battery it came with. It's a used battery. Came out of my stepdad's truck. He got a new one, and but it's still good. You know, decent. It's not horribly drained out. It came with these little plastic caps on it, which was really convenient for me because I was able to just strip some wire and just touch it to the connector and then press the cap down on top of it, and that held it pretty solid. You know, it's not going anywhere. I can tug on it pretty hard, and it's not going anywhere at all. The first mistake that I made was when I tried to hook it up to this thing. I hooked it up backwards, which I now know that you cannot do with direct current. You can do that with alternating current and not have to worry about it, but due to the nature of direct current, you can't do that. It actually, I heard a little pop and a little whine, and then I started smelling something burning. So I unplugged it, and even afterwards, I've plugged it back in now, and I get no reaction at all. So it's completely dead as far as, I mean, this is now a power strip. I can never put a battery in it at all. Okay, so moving on from that, basically, I already had a 12 to 120 volt converter. Now, this thing is rated for, let me see if I can get you to see that. It's rated for 150 watts, 300 watt max, you know, for like a surge capacity. So the most this thing can handle for roughly half a second is 300 watts. So really all this thing's going to be good for me is like charging laptops and mobile devices, things like that. That's actually what I used it for. I'd keep it in the car in case I had to take a laptop on a long trip, or just in case my cell phone died or something like that and you didn't have the car plug for the cell phone. I already had that, and I unscrewed this, and I slipped this, just a standard, you know, like laptop power cable, you know, it's between the wall and the power box. I think this one came from a PS2 or a PlayStation 1. You know, it's old. I just had a box of wires, and I pulled it out. It's just got a white and a black in it, and after my little fiasco, I made sure to label each one. This one goes to the positive, and this one goes to the negative, after I spliced it into this, because I did not want to fuck this thing up. This thing is very important, and it's my last one after I fried this guy. Okay, so, and what I forgot about when I started out the whole project was I forgot that I had this little guy. It's, you know, you just plug a 12-volt cigarette lighter male plug into that, and then this into the wall, and it's supposed to deliver power to any 12-volt car device. Like if I had a phone charger for a phone, and I didn't have one for the house, then I could just bring the one from my car and plug it into this and plug it into the wall. Kind of a, you know, big loop-de-loop for nothing, but it's, you know, if you build it, they say, if you build it, they will come. And they built it, and I got it a couple years ago. Actually, I'm not sure why I got it. I think I just needed a couple more bucks to get free shipping on something, so paid like $1 or $2 for this. I was like, hey, you know, never know when I'll need it, and here I am. I needed it. So basically, what this does is I'll plug this in to it, and when it's not plugged into the wall, it's still receiving power from the battery, and the light actually lights up. I'm not sure if there's voltage coming out of here. I never actually tested it. I doubt there would be. It just seems like that's kind of dangerous to pump 12 volts to 120 with what I'm sure is not very many like ohms of resistance or whatever it is, like the alternator in that thing, not alternator, transformer. The transformer in this thing cannot be very big due to the fact that it's supposed to go from 120 to 12. Now, these are just a lot of assumptions that I've had to make. I have absolutely no formal training in electricity. Everything I know, I've learned by trial and error and from Google. And I gotta say, in the information age, ignorance is unacceptable. If you don't know something that you want to know, Google it and you will know it. It's not acceptable for somebody not to know something these days. I mean, you can go to a library, even if you don't have a computer, you go to a library, get on the computer. It's just unacceptable how little people know these days. So basically, and I'm glad I didn't cut this thing, because later I found this. I was going to cut this and then splice it straight into this wire here. I was going to cut this one off of the box, cut it here and splice it in here, but then I figured, you know what, this was pretty expensive, and I don't have any spares of these to splice in case I break it, so let me just splice it into the plug itself. And it's a good thing I did, because about an hour later I found this in my box of electronics. So basically I just plug that in, and there it is. It's getting power, and then I can just plug it into the wall, and then it charges the battery. And I can do that while still using whatever I have plugged into this device. So let's say here we got a kilowatt. Let me unplug this. Unplug that there. Power on the power unit. Now this has to be plugged in to a power source for a couple of seconds, sometimes 30 seconds I think is the longest I've ever had to wait. I guess there's something inside of it that charges up. If you know what that is, if you know the technical terms for that, please leave a comment below. And so anyway, we're going to plug in this kilowatt here. Hard to do on camera. Alright, and we'll power on the power strip. And there we are, we're getting 118 volts. The lowest I've gotten is 116. The highest I've gotten, out of the battery anyway, is I think 119.2. And lowest was 116 even, which is well within the acceptable voltage levels of any American device on the market. If it's got the plug and you plug it into it, you will get power. The only problem that I have right now is the wattage limit. 150 watts is not a lot. Like my desktop computer uses, I think, 260, just the desktop, not including the monitor, the speakers, any other peripheral devices. So I'd blow this thing out probably if I plugged everything into it. Probably even if I just plugged the desktop into it. Maybe if I pulled some parts out, like the hard drive, put in an older video card, something like that, I might be able to get it. But this thing gets hot pretty quick when you're running it close to 150. If you keep it below 100, then it stays at a pretty reasonable temperature. It doesn't have a fan in it. I want to mount a fan to it, so that'll have a little better cooling for the applications that I intend to use it for, which is, like if our power goes out, then I'll have power to run the laptop, run the Wi-Fi router, cable modem, which I'm pretty sure would go out if we lost power anyway, but at least we'll know for sure. So here we are, back to the voltage. We got still running around 118 volts, right above it. 0 amps. Hold on. Keeps jumping back and forth. There we go. I'm not actually sure why it's doing that. I don't really understand what an amp is. I've tried, but it just says an amp is this, and the definition of an amp is based on the other things here, volts, watts, and that sort of thing, and I don't know what those really are either. So it's just like a loop-de-loop definition where the definition of one is based on the definition of the other. They're all based on each other. So I'm having a very hard time understanding it. So anyway, probably going to cut that out if I can. We got watts that are currently being used, so, jumping from 0 to point something watts, because basically it's just the kilowatt that's using power, because nothing's plugged into the kilowatt right now. volt amps, which is, I believe, Europe's version of watts. Like, we use watts here and volts, I don't know. They're pretty similar, is my understanding. Basically, volt amps is the voltage times the amperage. I mean, that's it. Like, literally, it's algebra. V times A. And then watts is slightly different. I don't know how they differ, but it's a very similar form of measurement. Okay, so, and then we can go to the important part here is the hertz. 58.8, 58.7, that's kind of low. I've never seen an outlet put out that few hertz. They're always 0.59 to 0.61. Usually 0.60 is what I see. In all the places I've lived, it's always been jumped back and forth between 0.5 something or 0.59 something and 0.60. Usually 59.9 is usually where it's between there and 60. It just flickers back and forth. This, I figure it's because I'm only getting 80% efficiency out of this little thing. It's not very efficient. Losing a lot of power out of this battery just by using it. That's getting, lost as heat and that sort of thing. And so I would attribute that to it, and the fact that it's a car battery. I'm jumping up voltages, and it's a car battery. It's not meant to be transferring the proper hertz. It's just meant to be amps and volts. Cold crank amps. I mean, I should be using a Deep Cycle Marine battery, but this is what I had on hand. All the research I've done has said, do not use these, do not use these, do not use these. But I've been using them since I was like 10, 11, 12 years old for experiments like this. And, I've had no troubles, but for the type of use, constant drain to nothing and then charge it up to full, drain it down to zero, charge it up to full. It's apparently way harder on the battery as opposed to a Deep Cycle Marine battery because of the thickness of the lead plates that are inside of it. But that's just my understanding. I may be wrong about that. I am not a professional. Let's see. Okay, so the power factor, which I have no idea what that does. Usually when I'm running devices on it, it usually says somewhere between 0.6 and 0.7, with, variations of that. It's a big mystery to me. Haven't gotten around to looking it up. And then the beauty of this device as opposed to this whole setup. This kilowatt is incredible. It's like $15-20 for one of these things, and to check the kilowatt hours. This is the main reason people buy these things, is to so you can plug your fridge into it, or your television, or your Xbox, or literally anything that plugs in here. You can plug a surge protector into it and plug a whole bunch of stuff into that and find out exactly how many kilowatt hours you're using. And then you hit that same button, and then it'll show how long it's been plugged in. So, you leave it in for 24 hours, and you'll see your full kilowatt hour usage over that 24-hour period. How many kilowatt hours that everything plugged into that device has used within 24 hours. And using that to get an understanding of how your devices use power and how much power they really use can help you understand what things in your home need to be turned off more often, or there's this thing people say it's called vampire power, where just having a device plugged in uses power. Like this thing, when I plug it into the wall, even if there's nothing plugged into it, that light is on, and it's using power. It is using power to power that light from the wall outlet. Now, that isn't a lot of power to power this little dinky LED, but that's energy. That translates directly to your the box that says your meter reader that the meter reader reads to determine your power consumption for the month, and that goes into your bill. This will spin that little disc a little bit faster. I know some of you have the electronic kinds now with the digital readouts, but for you old folks out there, you see the little spinning disc. You know what I'm talking about. That makes that disc spin just a little bit faster. Costs you that much more per month. So if you got anything, with lights on it and you're not using it, unplug that son of a bitch because it's using power. Leave that plugged in all year, you'll see, oh shit, this is a lot of power. All right, so just to give you a gist, that's pretty long gist, but that's one of my problems. And hopefully in the future, I plan on getting more batteries to add to this. I'll have a whole battery bank. I'm currently living in an apartment right now, and I get no direct sunlight here, none at all. I'm on the top floor. There's an overhang, so and then there's trees right out there. So even if I had a solar panel to put out there, I'd be getting no direct sunlight to power the panel to charge the battery bank. So what's the point? I'm here for another 10 months. So when I move out, I probably try to find a place that gets more direct sunlight, or at least has a backyard, maybe a townhouse or something, or a deck, or a balcony even. Really a balcony would be all I'd need. Set that solar panel out there, and it'll trickle charge. No matter how big the battery bank is, it'll charge it. The bigger the bank is, the longer it'll take. But it's a return on an investment, especially if I can get a bigger one of these. Especially if it's cheap. If I can get one for free, something like this, for free. I got this one for free. I found it in the recycle when I worked at Staples years ago. Somebody threw it away because the battery was dead, and you're meant to replace these. They were just like, fuck it, because we live in a throwaway society. And this has worked out as an advantage to me personally. I'm not saying I go dumpster diving or anything, but people have said, hey, I got this thing, it's broken, I don't want it anymore, you want it? And they always know I'm the guy to talk to about that. Sometimes I'll even pay people for it. This, however, I got for free, which is why I'm not too mad about blowing it up. Because it still is a power strip. These 4 outlets still work, and it is an incredible surge protector. I've blown up electronics plugged into an outlet, and this plugged into the same outlet, and my computer never even stopped running. Mostly thanks to the battery that used to be in here. Now, once I do get the solar panels, I'm going to have a lot more research to do as far as something called a charge controller, because based on the amount of sunlight that it gets, the voltage will actually vary pretty drastically. To the point where if it's too low, then it'll actually cause a problem for the charging if I just have it directly wired in. Now, if I have this charge controller thing, which I'm actually working on trying to figure out how to build myself, basically, you go to Radio Shack, you buy the right parts, you can build just about anything. But that is a project for when I am a little further my way through college. I'm currently getting my computer network engineering degree, which has a lot of electrical, training in it. So once I'm done with those classes, hopefully I'll have some a better understanding with some formal training with all that. But if I can get some more batteries in this, and this little device charges it real slow. It took me about 5 days to go from 12.3 volts to 12.72, which at the time of me taking this video, about an hour after I unplugged it, it had actually gone down to 12.68. So that tells me I didn't even charge it all the way. Now, which, probably have to leave it in a bit longer. That reading that I got of 12.72 was probably from the extra bit of voltage coming out of this thing to charge the device. This thing actually puts out, I tested it, it's 14.96 volts, which, that's, way more than one of these would need, but just right for charging a car battery. The only problem is it only puts out, what's that, 500 milliamps, man. Jeez. That's, that's what a cell phone needs to charge. That's how you charge a cell phone. And I'm charging a goddamn car battery off of that. Now, my understandings of these are pretty limited. I'd say I know a lot more than most about this subject, but I know a lot less than some people. So If anybody has any advice, positive or negative comments, I know everybody loves to hate on the internet, and don't worry, I can take it. Any hating you got saying, oh, that's a fire hazard, whatever, let me have it. Give me both barrels. If you think I'm doing something that's intensely unsafe, hazardous to my health and the health of the other tenants of my apartment complex, then please let me know. And I will do my best to do a little more research and make sure that I keep myself educated on the subject. Like I said, leave the comments below. Like it if you like it. Dislike it if you dislike it. I'm open to anything. Adios.